Hey guys, welcome to section 6, chapter 7 of the geometry program. And we're going to move away from our regular polygons and start talking about circles. So first we have a lot of things we've got to define. Things like a major arc and a minor arc. So a major arc is going to be greater than a semicircle. So greater than 180 degrees. And so, conversely, a minor arc is going to be less than 180 degrees. All right. A central angle, we talked about that a little bit when finding our area of regular polygons. And a central angle is an angle formed with the center of the circle. So that would be a central angle. That would be a central angle. That would be a central angle. So anything that's formed with the center of the circle would be a central angle. Congruent arcs. This should be pretty self-explanatory. So if you have two circles, or even if you have just one circle, and the measure of the arcs are the same, let's say that's 70 degrees, that's 70 degrees. The arcs are the same value of their intercepted central angle. So this would also be 70 degrees, and they would be congruent to each other. And sometimes you can have congruent arcs in the same circle. All right, so this is good to know that the arc has the same measure of its intercepted central angle. Okay, and then adjacent arcs. Those are going to be arcs that are next to each other and they share a single point. So if this was A, B, C, and this was O, center O, this arc and this arc are adjacent. Okay. You probably remember circumference is 2 pi r. So if you have a circle and you're given the circumference, let's say it's 3 centimeters. Remember, we're always using the radius, not the diameter, the radius. You could find the circumference by just plugging that in and then leaving it in terms of pi. So all of your answers I would like you to leave in terms of pi. Okay? And then one last one, arc length. Now notice the difference here in terms. Before we were talking about arc measure. So a measure of an arc, let's say this is arc AB, and this central angle is 90, then the measure of the arc is 90. That's different than the length. This is the measure. Arc length is the central angle, so it's the angle over 360 times the circumference. That's how you find the length of the arc. Okay, and we're going to do a couple of examples like that. All right, so let's jump into a few examples. So we have this circle with center C, and we want to find first the measure of each angle. So, or I could have said central angle there, but since we're in a circle, all of these angles are going to be centralized. All right, so we have this 130 degree angle, and we could see that angle ACB forms a linear pair with angle ACE. So that means that this angle has to be 50 degrees. And similarly, angle ACB forms a linear pair with BCD, which means this angle has to be 130. And of course, both those 130 degree angles form a linear pair with angle DCE. So ACB is 50 degrees, BCD is 130. DCE is 50. All right, and then you can find their intercepted arcs. So if you can extend, and then its intercepted arc would be AB. So that would also be 50 degrees, right? So if it's hard to see, just extend out your sides here, and the intercepted arc would be BD, and that would be 130. Similarly, DE would be 50. And then I tricked you a little bit. What about arc ABD, that whole arc? Now you're going to have to add those arcs together, right? To be 180. Okay, so there's a lot of questions like that where you're just identifying minor and major arcs, and then finding the measure of central angles and finding the measure of their intercepted arcs. So that should be pretty easy. The radius there is 4. So if we want to find the circumference is 2 pi r. And if my radius was 4, then my circumference is going to be 8 pi centimeters. Again, leave it in terms of pi at this point. I don't want you plugging it in the calculator. So then you have a few circumference problems, and then finally you have the length of each arc problems. And so remember that that formula of arc length was your angle over 360 times 2 pi r. So in this case, our arc length, it's going to be the central angle over 360 times 2 pi, and then r is 6. All right, and then do your fraction first. And you're going to get 1/3 times 2 pi 6. Multiply that together, and you're going to get 4 pi. Again, I should have hit some units here. Centimeters squared, let's say that's centimeters. Okay, one more example like that. Sometimes though you're going to be given the diameter, and you have to make sure that you divide that in half in order to get your radius. So we need the angle over 360 times 2 pi r. So our intercepted angle is 60 degrees times 2 pi, and then r is 6, right? Not 12 centimeters. And then this is 1/6 times 2 pi 6. And then arc length is just 2 pi. 2 pi, again, centimeters squared. All right. So that's it. It's really not that hard. I think you guys should do fine. Go ahead and finish up your notes, read through the examples, and begin your assignment.